myself Yash Kataria, and we are doing a case study on a situation in an electric scooter company. So basically, our company is in the market for last 2 years, and we are in case of market share, we are in the fourth position as of now, and we are having some major complaints from our customers. Like various issues are there which have been listed out in our case study, and we are here to analyze our case study and resolve the issues that we are having. And we are aspiring to become in the next 1 year to reach at the second place currently, which we are on fourth position. So let's look upon what are the issues we are facing and let's go through it, each one of it. So as you can see, the first issue is what we are doing in case studies. We are doing analysis of the application. So our electric scooter is linked to an application and we need to do some improvements in that part of it. So what are the top 10 features that we are aspiring to integrate in our application? So first is the real-time battery monitoring, which is a very critical feature to understand how much battery percentage is in it. And basically, this is one of the most crucial aspects of electric scooter because this helps because this is the one feature which decides whether the user will buy the electric scooter or not. Because it helps in understanding what are the battery, when will the battery reach critical level and all. So another one is navigation with Google Maps to guide you through the routes and optimal routes. Advanced vehicle diagnostic includes like you receive real-time vehicle status. How is it? Like you get battery alerts, you get maintenance alerts of it. And also in advanced vehicle diagnostics, we are approaching for currently our battery takes 6 hours to charge. We are looking forward to do that in within 4 hours. The complete battery will get charged of the electric vehicle. User-friendly interface. Currently, our app lacks with it. The application is having quite static, not much user-friendly interface. Security features are one of the key aspect of it, like geofencing capabilities or remote locking or unlocking of our electric vehicle when the scooter is moved without authorization and detailed location tracking of our electric vehicle. Performance mode selection like eco mode, normal, sport mode. Accordingly, it will provide you the support and speed will be accordingly adjusted, speed limits and overall how you will control over the ride. Document storage is basically as specified. Like basically, the app should allow users to upload and store important documents like registration certificates or insurance papers, service records, and users manual, etc. Kind of like this, you should be able to upload in the application itself, so it will be easier for you whenever you want access of such applications. Ride statistics like how much kilometers your vehicle has traveled and how much battery percentage is remaining, how much it can travel in that much battery percentage. Such things and social community features are like you should be able to connect with your other scooter owners so that if you have any issues, you can discuss with them. So it builds like a community of electric scooter vehicles. So basically, you can organize local meetups and group rides, which will promote sustainable transportation initiatives to the community platform. Weather integration, because this feature will provide that real-time weather updates, which will help you to suggest route modifications based on weather condition, and it will also help you alert users about the unsafe riding conditions if any are there. It will help in such way. So these were the more top 10 features of it. But what are the top five of this and why do they stand out and why we need to work upon them efficiently? So one, as I said, real-time battery monitoring, because it also helps in building trust with the technology. Battery anxiety is one of the biggest concerns for vehicle users, electric vehicle users commonly, and addressing this effectively would significantly help us to improve the customer satisfaction and confidence in our product. So it is necessary that we work upon it and make sure that it gets successful. Navigation with Google Maps integration. Navigation is essential for any vehicle app, and Google Maps is one of the most trusted platform for it. Now, this feature will add tremendous value by helping users to find optimal routes based on the that the scooter can complete with the available charging, which will reduce the range anxiety and improve the overall user experience of it. Now, the third one, as you can see, is advanced vehicle diagnostics, which assigns users about minor issues before they become major problems, reducing the repair cost and overall maintenance cost of it. Another big plus, as I said, that we are working on a completely full charge in less than 4 hours, which will make it easier to use daily. And security and anti-theft features. Security feature provides peace of mind to the users and can be a significant differentiator from competitors. Features like the geofencing or we can say theft alerts or locking system and will provide substantial value to the product. With rising cost of electric scooters, security becomes a major concern and therefore we need to work upon it. So that's it for this one. Now we will look upon into our next set. So next question which arose was about document storage, like what would be the design considerations when we are designing the document storage of electric scooter application, what we need to look upon, because all users will provide their essential documents like driving license, insurance, and insurance papers, registration certificates, which are quite useful, and we need to look upon the security features of it. Also, the user experience should be quite user friendly so that they will be easily able to upload, use it, or showcase it, any kind like it. So what are we looking upon the top 10 features of it, like while designing the document storage? Data encryption is necessary because the data should be encrypted and only authorized users should be able to access the data of it. Secure file upload, we will use HTTPS or SFTPS for safe uploads and limit the file size. So to block the malicious uploads, and this will ensure that the secure and reliable file transfers are done properly. Backup and recovery. So perform daily auto backups of the files which we have uploaded to secure cloud and allow recovery of deleted documents within 30 days. So this will ensure that the data is durability and availability is also there. sometimes if it gets deleted or something kind of like that. Auto scaling and load balancing. So the basically when we are uploading documents, so sometimes large documents gets uploaded, but this shouldn't lead to the app crash or something like that. So the system should work smoothly even with many users by distributing load and scaling as needed. And this will help us in maintaining the performance under heavy load. So even if it should be a scalable platform, like even if many users are there, this feature should work properly and independently. User-friendly security, like a predefined role should be there for easy permission management and icons to basically should be able to visually show secure content, and this enhances the security and usability aspect of it. Similarly, role-based access control, as I said, implement role-based access, allowing only owners to upload view documents. Accordingly, it only will be done. Two-factor authentication, which is mostly in all products as of now. So it will require OTP verification before document access. It can be through SMS or a Gmail, and this will add an extra layer of security to it. Chunk uploads is basically we will split the larger files into smaller parts. So basically, this will help in uploading, and it can also resume. Like your internet connection goes off, the document will when internet connection comes back, the document will start resuming when it was like 50% is done. So it will resume from 50% itself, kind of like that. And audit logs are basically like security audits will be run, like weekly scans to detect vulnerabilities, like weak passwords or outdated encryptions are there, any kind of like that. So it will help in it, or like monitor, it will also monitor failed login attempts and block any suspicious accounts in it. And we will also look upon cost-effective infrastructure of it. Like we will use cloud APIs to save cost because they are basically less costly, which will also ensure scalability and as well as reliability part of it. And this will ensure the optimized resources are optimized allocation. Resources are optimized accordingly. So that's it. Now, Samarth will continue.
Good morning, one and all. Myself, Samad again. And, now I'm going to proceed the PPT further. So the question is, list the potential reasons for any two of the issues which the customers have complained about, and write the test case scenarios you would use to test and ensure they have been fixed. So there are mainly the two potential reasons that we enlisted here. Right, not comfortable on gravel at high speed, and on the second previous slide, in the second slide from it, the issue is slow charging and sudden drop in range. So going back to the previous slide, so we have divided it, the means on the left hand side we have given what are the challenges faced by the users. On the right hand side we have given the test scenarios for easy understanding. So why is ride uncomfortable on gravel at high speed? Stiff suspension. Suspension is not absorbing bumps effectively due to being too stiff or not sized correctly. So it is about the measurement which which the designers are doing. Secondly, the solid under inflated tires, lack of air cushioning making the ride bumpy. And the third is heavy scooter. Weight increases the impact of bumps on suspensions and tires, and the small suspension travel. Limited shock movement prevents adaptive bump absorption. So this is all the designing drawbacks or the limitations which we have analyzed through this in our products. So what are the test scenarios? We have come up with the majorly four test scenarios for it. That is the vibration test, major vibration level on the gravel to ensure ride comfort. So we will conduct vibration test. Secondly, the suspension test travel checks the suspension travel under weight to ensure shock absorption. And thirdly, the pressure check evaluates comfort at different tire pressure on the gravel. So we are subjecting the tires to the different pressure on different gravel. So we are testing it. Thirdly, it is the heaviest rider test. Assess the ride quality with the maximum rider weight on the gravel. So it is subjected to user experience. So we are conducting the rider test for it. So by this we are tackling the problem of the uncomfortable ride on the gravel road at high speed. Now the second issue is, okay, slow charging and sudden drop in range. So we have found out the reasons for the slow charging. Battery capacity fading. Lithium cells loses capacity with each charge cycle, reducing energy storage. Secondly, faulty charging cables, damaged or dirty plugs restrict power flow, leading to slower charging times. Thirdly, charge or charger or scooter limit. If the charger's output is less than the scooter's maximum intake, charging remains slow. Now, BMS miscalibration. Incorrect current sensor setting in the battery can cause inaccurate state of charge readings. Now, it's the battery temperature. The battery's performance is subjected to the temperature. So extreme temperature can slow down the lithium cell charging and affects range reporting. As in a country like India where the temperature is fluctuating, this is a major concern. Slow charging past 80%. Many batteries reduce current after 80%, extending the time for the final 20% charge. Poor battery cooling. Overheating battery packs can cause the BMS to reduce charge speed to protect cells. And the last, sensor drift in BMS. Over time, error accumulate in Coulomb counting, causing SOC reading to drift. So on the right hand side, we have given the various test cases. We have enlisted the problems. Now this is the testing cases to ensure the problems are resolved. So temperature varying charge test. So we have the charge test, means we are charging at 10 degrees Celsius, 35 degrees Celsius progressively. Post 80% charge speed, 20% to 80%, it should be less than 3 hours, 80% to 100% less than 1 hour. Cycle life capacity test. Cycle 500 times capacity more than 90%. Connector and cable checking. Inspect and clean. Charge from 0% to 50%. BMS calibration check. Set full charge and reset SOC. Okay, so BMS SOC accuracy, charge and discharge, error less than 5%. Full charge time check, charge from 20% to 100%, time less than or equal to 4 hours. And temperature varying test that we have already discussed. Now this is what I've got about this question.
This part, what are the features? We discussed about the features part. What are the top 10 features of it? Now, what we will do is we will do a relative priority on it. Like we will mark them from P1, P2, and like we will mark it from 1 to 2, which are the most top priority features of it. So we'll be able to work accordingly in it. And we have analyzed based on some decision factors, which includes like customer complaints, which is the main source of it. Cost constraints also, like we avoided high effort P2 features. We will first look upon the lower scale ones. Now the case study that we did completely based on this, we did and some research. And basically also one factor which is the most important is return of investment focus. Now the P1 features align with the sales target, like which will help us in increasing our sales target by 50%, and which addresses are the core issues of it. Real-time battery monitoring, which is the most crucial feature of it, which directly solves the complaint of charge running out without warning. And the value of it is quite high because it will provide the return of investment also high, and effort is medium required in it. The second feature is about user-friendly interface design, because user-friendly interface design is quite important because it addresses the clumsy UI complaint, which helps in like basically the most of the users use applications based on it. So it fixes it, and poor UX risk apps abandonment. And the value of it is high, and also effort is required high in it. Now navigation with Google Maps is also important for which is critical for route planning, which is requested by the company itself plus Gen Z. If you consider about Gen Z, they require it quite. So the value it is high, and effort required it is medium in it. Security and anti-theft features quite necessary because it reduces the theft risk, and it helps in differentiating from our competitors. And which is also like geofencing, which works best for Gen Zs. And value it is medium to high, and effort is quite minimal required in it. Advanced vehicle diagnostics, like which helps in preventing breakdowns, and it aligns with the zero key issues goal of it, global goal of zero key issues. And the value it is quite medium to high, and effort is minimal. And document storage and management comes next, which is also kind of like company requested feature for legal or insurance docs. Value is quite medium level, therefore value and efforts. Performance mode selection is quite required also because it helps in enhancing the riding experience in case with Gen Zs, or it helps into appealing the customers, performance users and all. So it is required, and value it will be a medium, value effort quite low, it will be required. If we talk about ride statistics and state, is quite useful to get insights about R, and it is also useful for eco-conscious riders, but not quite a priority. Therefore, we put it down accordingly. So value and efforts are low. Weather integration, if we talk about, it helps in route planning, but it kind of likes overlaps with maps also. So it is a kind of like low feature, low value feature, and medium effort, scale effort is required. And if we talk about social and community features, it is like kind of like for appealing the users. So nice to have for brand loyalty, kind of like that feature. And value low, but yeah, effort high is required in it. So that's it, as I said. Now we will move on to next.
So good morning, everyone. So I will be explaining the next two questions related to case study. So let's see. The first question is about the integrity of the app and the scooter itself. So first thing is on the left side, we can see what root cause of the problem in case of integrity, and on the right side, we can see that how we can improve it. So let's start with the root causes. So first one is weak network in scooter. The scooter may be using a poor internet connection or a slow module to send data. If the signal is bad or the technology is outdated, the data won't reach to Google properly, which may cause the delays in the updating data on the app or integration of the app with scooter. The next one is cloud server overload or DIM. If the company is using basic or a low cost cloud, it may not be able to handle many users or a large data smoothly, which is again also the root cause of the data delay. Then the next one is the real-time communication. So in the real-time communication, maybe the data is being sent after some time instead of immediately, which again also the sub-problem of weak network connection. App not syncing often, so it is also related to the weak network connection or the cloud server being slow. And again, the next problem is related to the data storage or document storage, as the feature explained by Yash. So if the data files are too large, they are not compressed, it may take longer time to upload or download, and so it will take longer time to display on the application. So how we can improve this? So use real-time data protocols like MQTT or Firebase, which helps to send and receive data instantly. Then use faster cloud servers so that there are no delays. Then in case of large data or large files, we can use data compression, or we can just compress those files. Then in the background, while the application is running, in the background, we can keep updating it by accessing the required permission through mobile. Then improve internet models. So in the scooter itself and on the phone or in the application, we can use improve internet models to tackle the connectivity problem. So let's take to the next question. So the next question is about that the company wants to integrate an AI ML model. So question is about which data should the app collect for the model to train on, and how can it be useful? So let's see the data that can the application collect. So the first one being the battery data, how fast battery is draining, how much charge is left, or how long it takes to charge. Then the next one is brake and throttle, which is useful for determining the mileage of the bike or how much battery will be used in terms of acceleration or deceleration. Then travel time distance, how long the user uses the bike and how long distances he covers in one single charge or in one single trip. Then next one is speed and the road. What is the condition of the road he is driving on? Based on that, we can determine whether he decelerates more often or accelerates more often, and speed data basic. Then next one is the GPS and route. Record his GPS coordinates and to get the basic idea of what are the routes he usually travels on, so we can improve those and provide him with routes with shorter times. Then next one is system errors warning, which is basically like engine warning or battery warning, etc. So based on this collected data, what we can recommend to the driver to overall. So first thing we can recommend is whether his battery is low, he needs to charge the battery or not. Then road condition. As we know from the road data that we collected on what roads he travels, we can recommend him that there are some there is traffic on the road or not, or what are some other better options he can take. So next point also got explained in this, which is route optimization. So basically tell him with, provide him with the alternate route which will require less time to travel. Then the driving style. So we can suggest the driving style based on how often he decelerates or accelerates, or the time he takes, or the distance he travels. Brake uses. So how often he uses the brake, or what are the chances of his brake plates getting damaged. So we can recommend that to the user. So the enhancement cycle is explained on the bottom right side. So what are the enhancement actually? Predict the battery replacement, suggest smarter routes, recommend service date, then identify unsafe patterns, provide personalized tips. So let's head to the next question. So the next question is about the what are the business objectives, scooter products feature, and changes in the UI or changes in the UX to improve the trust between users and the company. So what are the business aspect, what are the business objective in terms of in view of company? So first one is to increase the sale. The company should aim to boost their sales by 50% to achieve the second position in the next 1 year, as mentioned by Yash. Then next is to improve profitability. So shift from 10% loss to 10% profit per vehicle to ensure the financial stability of the company. Then achieve operational excellence. Ensure zero key operational issues post launch to streamline the processes. Then enhance the market position. As they rank fourth currently in terms to gain the second place, they have to increase their sales, profit, and all the aspects which contribute to the market share. Then the next one is related to the user, which is scooter product features. So first product, as these are the features explained by Samal. So first one is the fast charging. So provide, instead of taking 6 hours, it should take 4 hours to charge to the 100%. Then touchscreen dashboard. So provide a touchscreen dashboard on the scooter handle to basically let user look through the features and or his Google Maps or the connectivity of the scooter with the. Then next one is Google Maps, which I already explained, which will be shown on the dashboard of the scooter itself. Then reduce the weight to avoid bumpy rides or to increase the mileage of the bike. We can reduce the weight of the bike. So next one is document storage, which is the feature of the application, not scooter. So where we can upload or store our documents, which will be useful in many cases. So let's move to the next slide and the remaining part of the answer. So the next one is the UI enhancements. So mobile app design. So basically we have to achieve a simpler, faster, and modern mobile application design, which will be easier for the user to navigate to. Then organized layout, clear battery, speed, and navigation information in the layout. So these will be the main features of the application, which needs to be shown or which needs to draw the attention of the user. Then next one is the live updates, or we can say real-time updates and notification delivered without any delay. Tablet dashboard UI. So tablet dashboard UI, it is basically the dashboard that we are providing on the scooter itself. Okay. Next is the user experience upgrades. So ride smoothing. Basically, it is related to the bumpy ride. So as discussed on the previous slide, we are tackling this by reducing the weight and improving the suspensions of the bike. Then the next one is battery management. As the user will be getting all the reminders about his battery life, battery health, the battery management will be easier. Then the next one is data synchronization. Seamless data transfer between devices, scooter, and the cloud to ensure that there is no delay in the update or display of the information on the application and on the scooter dashboard itself. Then next one is the driving recommendation. So as said on the AI integration, we can give driver the recommendations, which will also help improve the trust of the user with the company and also let him achieve the highest mileage possible or etc. So next slide will be explained by someone.
So I would be explaining this question. What do you think are the business metrics which are being used by the company to decide what to focus on for improvement and changes? And what engineering metrics and measurements do you think should be looked at considering the complaints from the customer? And do also give the reasons for the metrics and the measurement you have selected. So we have selected the business performance metrics, and on the second slide from this, we are explaining the engineering metrics. So moving back to the previous slide. Okay, so business metrics. So it's a sales volume growth, measures the number of scooters sold monthly, quarterly, aims for 50% sale increase in the 6 months. Secondly, the market share, trace the company's portion of the total scooter sales. Goal is to move from 4th to 2nd place in the year, as explained by Yash. Profit margin, calculate profit per scooter as a percentage, aim to shift from a 10% loss to a 10% profit, and trace the and the production efficiency, trace the cost of material and labor per scooter and lower the cost and profit without price increase. Okay, so the defect rate, measure the number of scooters for following quality checks and aim for the zero error issue in the first 3 months. Section, ask buyer to rate the happiness on the scale and happy customer who sales through repeat purchase. So which business metric should be prioritized? This is the reason why we are using it. The sales count, help understand market demands and sale performance, customer rating and complaints, gauge customer satisfaction and product quality, key issue in 3 months, ensure smooth production launch and operational efficiency, and profit per scooter, determines financial health and profitability. So by using business metrics, we are tackling all this problem. Now the next slide. The next slide talks about the engineering metrics. So it is the vibration level, measures scooter's route, mean square acceleration on rough roads, lower RMS means smooth rides, suspension travel, record suspension movement in millimeter under load, and more travel absorbs bump on the non-tread roads. full charge time measures hours to charge battery from 0% to 100%. Charging time must be under 4 hours. Okay, so battery checking fade, check battery's capacity drop per charge discharge cycle, and low fade means longer battery life, as most of the customers were having this issue. SOC accuracy compares battery meter reading versus real charge left, error less than 5%, stops unexpected scooter shutdowns. App notification, let us say, as most of the users complained that the app was clumsy, measure the time between the scooter event and the push alert. Alert must be faster for users to see fresh info. App crash rate counts app crash per 1,000 user sessions, and less than 1% crash rate makes app stable. In scooter curb weight scooter without right to determine weight in kilograms. Lighter weight improves handling and range. So engineering matrix, why we are using it? So this is the reason: ride quality, focus on shock quality, tire grip, and scooter balance to enhance ride comfort on rough roads. App usability, enhance app speed and ease of use by testing on various devices and gathering user feedback. Weight reduction, reduce scooter weight by using lighter materials and removing unnecessary parts. And charging efficiency, it improve charging time, battery health, and sensor accuracy to prevent sudden power off. So this is why we are using engineering metrics. All this were on the left hand side, all were the possible reasons we find out, and on the right hand side we are giving the reasons why we are using. So finally, to the concluding slide. Thank you and have a nice day.